Good morning, class. So we are on to the second lecture of this course, CSE 301 Object-Oriented Programming. Today we are going to look at 5 different topics. The first one is error handling. Next, we will look at the importance of scope. And then we consider operator overloading, multiple inheritance, and finally object operations. Please, it is very important for you to pay attention so that you will understand every concept we are going to discuss here. And also it's very important for you to note down questions where you have where you do not understand the concepts that we are going to discuss. All questions should be directed to my email ayei.ibor@gmail.com. That is ayei.ibor@gmail.com. Error handling. Now, when you're writing a program or a class, any series of statements that constitute code or program or a class may come with problems. If your code has the capability to detect and trap these problems, which we call error conditions, then the error can be handled in several ways. There are approaches to handling errors because it's unlikely to have a program that is perfect. I don't think anybody at your stage can write a program without errors. There are always error conditions. Even professionals write programs that throw errors. So errors are part of programming. Whether you are writing in Java or in C++ or in Objective-C or Visual Basic or C#, there must be a part of that program that will come with some problems. It could be semantic errors. It could be syntax errors. So these errors are always there, but what is important is your ability to handle them. So how do you react to error conditions in your program? So we look at 3 approaches. One is fix the error. That is, fix it. You fix the error condition, and the program continues to run. Or you ignore the problem by squashing it. Or you exit the runtime. So these are 3 different approaches that you can use to handle error conditions. But let's go. Now we can consider these approaches in terms of the following. Ignoring the problem, which may not be the best approach. Of course, if you ignore the problem, your program will terminate, prematurely terminate, and you will not have the required output. I don't think anybody who is serious about writing programs will just stop or discontinue the program because of an error condition. You must find ways to fix it. The other one is the next option is you're checking for potential problems and aborting the program when the problem is found. So you can check for the problems, and then when you find one, you terminate the program, you abort it, the program stops. Or checking for potential problems, catching the mistake, and attempting to fix the problem. So you can check for the problem, you now catch or arrest the problem or note the problem, and then attempt to fix it. I think that is a very good option. So you check for the problem that may lead to your program aborting. You note it down, you arrest it, you catch it, and then you fix it. See, that is a very good option there. Then the last option here is what we call an exception. You throw an exception, which in recent times is a preferred way to handle the situation. So most modern object-oriented programming languages depend on this last option. So when you are writing a class or a program, you throw an exception when you find an error condition which handles the situation. So it's just like you are driving your car and you say, if I see an obstacle on the way, I divert to the nearest safe place. So that is like an exception because that was not your intention. Your intention was to go to somewhere. Maybe you're moving from point X to point Y. But if you see an obstacle on the way along the route from point X to point Y, you divert to a safer place, maybe point Z. You know, that diversion is an exception because it was not originally part of your plan. You see, and your destination is not point Z, it's point Y. So that exception always helps to control how the program executes so that the program doesn't terminate. So that error condition can be handled and other parts of the program can execute that do not bring up an error condition. So let's look at these strategies in detail. Ignoring the problem. The primary directive for all applications is that the application should never crash. Take note. Even you as a student, you're writing a program and it crashes, you feel very bad. So the primary objective is that it should not crash. The program you're writing or the application you are developing should not crash. Now, if you ignore a potential problem, it is a recipe for disaster, of course, You just ignore the problem that, there's no, the problem can be there. And so how will your program bring out the desired output? Because before you start working on a program or a class, you have anticipated output. You have an output that you are looking at, expected result, what you expect the program to bring out. So if you ignore, if there's an error condition in the program and you ignore the error, then the expected result can never be generated or produced because there is no how the program will continue. So you should not ignore any known problem. Any known problem in your program or in your class or in your code should not be ignored. If you do not handle your errors, of course, that program, that application will terminate. Or it can continue in an unstable state. Of course, errors create unstable uh, states in the program. And I don't think anybody will want to have an unstable program or class. That will mean that you have not, or you are not ready to solve the problem you have identified using that code or program that you're working on. Well, in the latter case, you might not even know you are getting incorrect results, and that can be much worse than the program crashing. So if you if the application is allowed to continue in an unstable state, you may have erroneous results. You may have results, but the results may be erroneous. And when results are erroneous, of course, you know that if those results are used further for any kind of processing, assuming it is, let's say, in a healthcare system or a patient monitoring system, and then you have erroneous results where you read or where the diagnosis is incorrect, and then you now perform prescription, or you prescribe some medication for the patient, you know the consequences because your application continued in an unstable state and generated erroneous results. Then the outcome of that is very, very dangerous. If it is in a critical system, then lives can be lost, and I don't think anybody will want to be part of such a situation. So if you decide to check for problems and then abort the application, well, the application can display a message including that a problem exists. So you can write your program such that when it detects a problem, it displays a message to indicate, to tell you that a problem exists. For instance, if you are using most of the times, if you are using a computer, you notice that when you perform an illegal operation, it tells you the operation is illegal. I think most of you, I think everybody should be familiar with that. So the application will exit and the system will return to a stable state, and that is very important. So where the application terminates, the system goes back to a stable state. Otherwise, the system will become unstable all throughout. That's why in the typical computer system, where an error is thrown, where you see an error condition, maybe an illegal operation or any form of error condition that is displayed on your screen, and you click OK, the system rewinds. It goes back to the state it was before the error, so that it can be in a stable state. Otherwise, if it continues in that instability, then it can lead to several other problems. The system can close or open files and force a restart, but this is not an optimal solution to the error you encounter. So, can close all files and force a restart. Sometimes it can just close the files and do nothing. Go back to previous state before it started running. So the next option is checking for problems and attempting to recover. I think it is also a good option. You can check for potential problems, you catch the mistake and attempt to recover from this situation. And this approach is more superior than the ones we have just mentioned earlier. So the problem is detected by the code, and the application will now try to see where the problem is and then fix it. For example, if you look at this code, if x is equal to 0, x is equal to 1. So at any point that it encounters a 0 value for x, okay, it sets the value in x to 1, or the value of x to 1. Before performing the operation z is equal to y divided by x. If it doesn't set the value of x to 1, and it performs the operation z equal to y divided by x at the point where x equal to 0, that's a division by 0. And I think we know what that will trigger an error condition, and it can lead to premature program termination. So without including the conditional statement, a 0 may make its way to the divide statement, as I've said, and that can result in a system exception. because we cannot divide by 0. I think there is no known mathematical manipulation or formulation that allows you to divide by 0. But if you catch the exception and set the variable x to 1, it will not lead to a system crash. But the result will be, it will give you a correct result, depending on the value of y. Since x is not 0, whatever the value of y is, if you divide by x, you have the correct result. You see, that is just, it's a very good option. And it can help you to recover from error conditions. Your program will continue in a stable state. So, what will be the better solution? Well, we prompt the user to re-enter the proper input value. Although the error checking techniques mentioned previously are preferable to do nothing, yes. So the techniques we have mentioned earlier, they are preferable to doing nothing. So you provide a continuous statement that changes the value of the let's call it troublesome variable. Okay, so it changes that value, the value of the variable that contains 0. So it changes it to 1. So that any division operation that involves that variable can produce correct results, and the program will continue to execute. But there are also a few problems with the previous approaches we have discussed. Because if you detect a problem in your code, it might take time, because it is not easy to determine where a problem first appears. I don't think any programmer will tell it is easy. If you are debugging a program, if your program returns an error condition or throws an error, and you are debugging it, you are trying to find where the error is. Sometimes it is not straightforward. So, although some compilers will indicate the line number where that problem uh, occurred, but most of the times that problem may be the result of another problem, a preceding problem. So you need to trace to get to the initial problem that started the whole error condition, and doing that can be very, very tedious. So it is important to design error handling into the class from the start. So yes, so while you are writing your class or your code or your program, make sure there is an error handling aspect. So some part of the class or code should take care of error handling. So it handles all the errors without the program going into an unstable state. So now let's look at the best solution. The best solution here is what we call throwing an exception. Most object-oriented languages, they have this feature. They have a feature called exceptions. Well, what this means is that there are unexpected events that occur within a system. So you are anticipating that an unexpected event will occur, and you have sometimes, let's say, you have a plan B. So you have an alternate plan, an alternative to the initial plan. So that alternate plan serves as the control um, situation. So it takes care of whatever error or errors that will occur, whatever problem or problems that may arise from the execution of the program, and then handles them quietly while the program continues to do whatever it's doing. So we can detect and handle problems in a program with exceptions. And to do that, we use a catch and throw keywords. Most languages like Java, C Sharp, C++, Objective-C, and Visual Basic, the catch and throw keywords are very useful for um, handling exceptions. So what this means is that we have a specific block of code which you write to handle a specific exception. So exceptions, there may be more than one exception in your class or your program or your code. There may be one, of course, you should not anticipate one exception. There you can have several exceptions, you can have several situations that may trigger error conditions. So you will need to write all the exceptions, all the blocks of code to handle all the exceptions you are anticipating. So that is the trick. And this approach it solves the problem of trying to figure out where the problem started and then unwinding the code to the proper point. I told you about that. It is not a straightforward thing because if the compiler says there's an error at line 10, that error may have emanated because of a syntax error or semantic error at line 5. So it's not always straightforward that that statement triggered the error. The error may have been triggered because another statement, the preceding statement, is faulty in some way. Maybe there's a syntax error or semantic error associated with that statement. So if you need to fix that error, what do? You unwind, you start to trace back, and that takes a whole lot of time. So to take off that complexity, you just anticipate some error conditions and then you write exceptions which can handle these problems or these errors at the point where they are detected. So let's look at in Java we can use a try and catch block to handle an error condition. So you see try, please take note that indentation, that the arrow there, the small arrow, the blue or sky blue arrow before try should not be there. The block should match the closing brace. So the first brace after try should match the closing brace after the comment. Take note of that. So in case you are writing a try block, the brace, the try statement must align with the closing brace. So because the scope of the try statement is within this opening brace after the try statement or the try keyword and the closing brace after the comment in the catch block. Take note. Otherwise, if the indentation there is not correct, then if you write the program, you have an error triggered or thrown at you. So try the possible error prone code will be there within the try block, and then you have the closing brace for the try block. Then you have catch. So the catch block is where you put the code to handle the exception. Catch. Then you have a parameter there. exception E. So E is an instance of this exception in the parentheses. So you now include the code to handle the exception and close the brace. Please, the braces must be aligned, must match. Take note. Now, if an exception is thrown within the try block, the catch block will handle it. Take note. It's very important for you to know. If there's an error condition triggered within the try block, the catch block will handle it. And when an exception is thrown while the block is executing, then the following will occur. The first thing that will occur is that the execution of the try block is terminated. So if you have an exception thrown while the block is executing, the following will occur. The execution of the try block is terminated. 2. The catch clause. The catch clauses, or the catch clauses, because you can have more than one catch clause. All the catch clauses are checked to determine whether an appropriate catch block for the offending exception was included. Because every exception has a catch block. So you will need to include the catch block for the offending exception. You have a try, you must have a catch. You have a try, you must have a catch. So the catch block is to handle the exception thrown at the try block. So we can have more than one catch clause per try block. Take note, there can be more than one catch clause. So we can say try, catch, arithmetic operation exception, or catch, string concatenation exception, or catch input output exception. So you can have more than one try catch block for one try block, because the exception, the error condition that is triggered may need several ways of handling them. Take note. Or may need several ways of handling it. So number 3 is that if none of the catch clauses handles the offending exception, it is passed to the next higher level try block. So if you have a try block and there are catch blocks, corresponding catch blocks which are associated with that exception, that try block, and none of them handles the offending exception, then the compiler will start checking for a higher order or higher level try block. Maybe that higher level try block may have triggered the error condition, which is to be handled by a certain catch block somewhere within the code. Now, if the exception is not caught in the code, the system ultimately catches it, and the results are unpredictable. That is an application crash. So if it checks through and there's no corresponding try block for a certain catch, so you cannot include a catch without the try block. Take note. So there's no corresponding catch try block for a certain catch block, then the program will terminate and then you have unpredictable results. That is not a good situation, and you should never try to fall into such. Now, if a catch clause is matched, so if it finds a catch, if it matches a catch clause with a try block, the first match encountered, the statement in the catch clause are executed. So if an error that was triggered by a try block is caught by a catch block, then whatever is specified, the code specified in the catch block will not be executed. Then execution resume with the statement following the try block. Take note. We can consider a Java example for catching an exception. So let's look at this example for catching an exception. You have x equal to 0, scanner input equal to new scanner system.in. Of course, that is for input. Y is input.next int, so it receives the value of y at that point. Of course, y is an integer. Although this should be initialized, that if it is a full, if it is a program, if it's a full program, you need to declare the values of x and y. But this is just a snippet. It's just a section of the code. So try. So possible error prone code. So we have y equal to y divided by x. At this point, x is still 0. So there's going to be a problem. So let's see, let's continue. So you can see the way the try block is aligned. So the try and the brace, the closing brace must align. So the catch and the closing brace here must align. So the indentation must be at the same level, not different levels. If you put different levels of indentation, then the program would not execute. Of course, that is an error in itself. So catch arithmetic exception. Arithmetic exception. E is an instance of that exception. So what is the code to handle the exception? So you see the comment there, code to handle exception. That is the code. System.out.println, printline e.getMessage. So we now try to display the type of exception that is being handled here. Already specified that it's an arithmetic exception. So it is an exception that is related to an arithmetic operation, like I've mentioned earlier. Then x plus plus, I increment the value of x by 1. So where the error is triggered, where we find the error situation within the try block with the statement y is equal to y divided by x, with x still having the value of 0. Since we cannot divide by 0, we try to catch that exception by providing an alternative, saying that, okay, tell us what exception occurred, and then possibly for the next operation, increment the value of x by 1. So x is no more 0, x is now 1, and subsequent statements, division statements that encountered x will not throw an error, because at this point you have handled the exception by incrementing the value of x by 1. So system.out.println, so this is a statement that will execute after the try block. The exception is successfully handled. So that is just to indicate that we were able to handle the exception. Now, take note of this. Take note of this. You can catch exceptions at various levels of granularity. Okay? What that means is that you can catch all exceptions or check for specific exceptions, such as arithmetic exceptions. So you can catch all exceptions, or you can catch specific exceptions. So the exception handling issue occurs at different levels of granularity. So because you can have more than one try block, and of course you can have more than one catch block handling for handling exceptions. So at whichever point an exception occurs, you can catch it depending on the state of your code. So from the example above, the division by 0, since x is equal to 0, within the try block will cause an arithmetic exception. And if that exception was thrown outside the try block, the program will most likely have been terminated. Of course, if it is thrown outside the try block, if you don't put that try block, the program will terminate because you can't divide by 0. But since the exception was thrown within the try block, the catch block is checked to see whether the specific exception, which is an arithmetic exception in this case, was anticipated. So we anticipated that exception and then we provided the catch block to handle it. Now with the catch block containing a check for the arithmetic exception, the code within the catch block is executed. So we execute the code within the catch block to handle the exception by incrementing the value of x by 1. Take note. And after that catch block executes, the try and catch block is exited. So we now go out of the try and catch block, and the message, the exception successfully handled, will appear on your console. So this is actually the logical flow of this process. This is exactly how it happens. The system throws an error, it throws exception, the application catches and handles the exception, and the system is happy. So yeah, it's not back, it's in a stable state. If you do not, if the second step, or your application catches and handles exception, is not included in your program, the system will be unhappy because it will crash, or it will terminate, and it will be in an unstable state. So if there was no arithmetic exception included in the catch block, the program would likely have crashed. Now, I think that is well understood. So you can catch all exceptions by using the following code. So any exception you want to catch, just use this code. All the exceptions in your program, you can catch them by using this code. Try, possible error prone code, catch, exception E. E is an instance of exception. So you now have the code to handle it. You now write the code to handle the exception. So you can see the indentation all aligned. Now the exception parameter in the catch block is used to catch any exception that might be generated with within a try block. Okay, that's self-explanatory. Any question? If you have any question, please note it down and send it to my email ayai.ibo@gmail.com. Or if you don't know the spelling of ayai.ibo@gmail.com, then I will spell it out. ayei.ibor@gmail.com. Please, no spaces included in the email address. So let's look at the importance of scope. Like we have seen the try and catch block, or we have seen the class and the constructor of a class, or the methods in the class. Each of these has scope. Scope defines where variables are visible within your code or program. Now, multiple objects can be instantiated from one class, but each of these objects usually will come with a unique identity and state. And this is very important. Each object is constructed separately and is allocated its own separate memory. But some attributes and methods may, if properly declared, be shared. Take note. Some attributes and methods can be shared by all the objects instantiated from the same class. Yes, some attributes and methods in a class can be shared by all the objects instantiated from that class. Therefore, they share the memory allocated, for these class attributes and methods. So whatever memory is located for the class attribute and method is shared. But take note, we discuss constructors, and we say in the class there must be a constructor, whether you provide an explicit one or the compiler provides an implicit one, which you will see if you compile the bytecode. The constructor is a good example of a method that is shared by all instances of a class. So any instance of a class will share the operations within a constructor. So whatever a constructor is written to do, every instance of that class will share it. So even if you instantiate that class 10 times, of course, they will share the same variables within the constructor and other operations. Take note. You know that methods represent the behavior of an object. We have said that before. In a class, methods model the behavior of that class, while attributes model the state of that class. So any object instantiating a class will have the behavior of the methods in that class and also the state of that class, which is represented by attributes. So there are three types of attributes here. We have the local attributes, the object attributes, and the class attributes. We are going to what are local attributes? And local attributes are owned by specific methods. You see, so when you write a method, all the variables you declare within that method are local to that method. So they are owned by that method. You can't see them outside. That you can access them outside that method. Take note, you can't access them outside that method. For example, if you look at the following code, public class number, public method 1, int x, public method 2. Of course, there's no declaration, there's no variable declaration there. Now, that method 1, has a local variable called x, which is an integer variable. Now, this integer variable is accessible only inside that method. Only inside that method. On the other hand, the method 2, has no idea that the integer x within method 1 even exists. It has no idea because it's local. The scope is only visible within that method. So the scope of x is just within the method 1. Now, at this point, the scope concept comes in. Now, attributes and methods exist within a particular scope. Take note. All attributes and methods in any program, or well, let me make it a general statement. All statements, all variables and functions, I think that's more general, exist within a particular scope. So in OOP, in object-oriented programming languages such as Java, all attributes and methods exist within a particular scope. Now, in this case, the integer x exists within the scope of method 1. If you consider languages, OOP languages like Java, C#, C++, Objective-C, we delineate scope by curly braces. So we define or specify scope using curly braces. Of course, you know the curly braces. It's not parentheses. You can see the curly braces have been included within parentheses to tell you what we are talking about. The curly braces, they are not, they have a coil at the center, not straight parentheses. Now, in the number class, there are several possible scopes. All you need to do is just to start to match the curly braces. So by the time you start matching the curly braces, then you will understand the different scopes we are looking at, that we are talking about. Now, the class itself has its own scope. Take note. The class itself has its own scope. And each instance of the class, which we call an object, also has its own scope. So, in this case, both method 1 and method 2 have their own scopes as well. So, method 1 has its own scope. Method 2 has its own scope. So, these two are different. The local variables you declare within method 1 cannot be seen by method 2, and the local variables declared within method 2 cannot be seen by method 1. Method 1 will never know that variables locally declared in method 2 ever exist or even exist. And method 2 will never know that variables declared within method 1 ever exist. Now, since x lives within method 1's curly braces, when we call method 1, a copy of x is created. When method 1 terminates, then that copy of x that was created will be removed because the scope is local to method 1. And let's look at this code here. Public class number, public method 1 int x, public method 2 int x. So you can see that method 1 has a local variable, method which is an integer variable x. Method 2 has a local variable which is an integer variable x. Now this example has two copies of an integer x in the class. The class is number. There are two copies. The first one in method 1 is local to method 1. The second one in method 2 is local to method 2. So the scope of x in method 1 is within method 1, and the scope of x in method 2 is within method 2. And they are two different things entirely. So remember that method 1 and method 2 each has its own scope. Therefore, the compiler can tell which copy of x to access simply by recognizing which method it is in. Simple. So they have the same, they have, each method has its own scope. So the compiler will not be confused because by recognizing the method it is in, it will know which copy of x it is accessing. So you can think of it in terms of this, method 1.x, method 2. So method 1.x, method 2.x is like you have the same surname but different first names. Of course, if your name is John Smith and you have a brother who is called James Smith, you are two different persons. Because for the fact that your surname is Smith doesn't mean you are the same person. You can have different behaviors. You behave differently, you react to issues differently because you are two different persons. So that you have the same surname, just like we have method 1.x, method 2.x, does not mean the two methods are similar. Method 1, the first before the dot, that method 1 is like the first name, it's like your first name. If you are sharing the same surname with someone, method 2 is like the first name of the other person. So they are two different. So the compiler sees them differently. Okay. Where we have count assign the value of 1 in method 1 and the value of 2 in method 2, but never declared within the method. You just have one declaration outside the method. So this one here, from this, because here we declare count outside the methods and also the local declarations within the methods. In this case, 3 totally separate memory locations have the name of count for each object. So the object owns one copy, method 1 owns one copy, method 2 owns one copy. So if you want to access the object variable from within one of the methods, say method 1, you can use a pointer called this. So if you want to access the object variable from one of the methods, since each one has its own declaration of the same variable name, and you want to access the one that is declared outside the method, then you can use a keyword or a pointer called this. I think this happens in Java also. You see based languages, C++, Java, and the rest. So, Objective-C and the rest. So you have public method 1, int count, this dot count equals to 1. So if you notice, if you look at the code, this code segment, public method 1, int count, this dot count equal to 1. The line this dot count equal to 1 is a bit curious. I think you should say what is the meaning of that line. Now what that means is that we are using the this keyword to direct the compiler to access the object variable count and not the local variable within the method body. So we are saying that whatever value that is assigned to the object variable count, which is declared outside the method, should be used. We are assigning the value of 1. That is the appropriate explanation. We are now assigning the value of 1 to the object variable count, which is declared outside method 1 and method 2, not the one that is local to method 1, the one we have in count just above it. So the value of 1 will not be assigned to this local variable, but the object variable. Take note. So you should know that the keyword this is a reference to the current object. Okay. So let's look at class attributes. Well, we have discussed earlier that it is possible for 2 or more objects to share attributes. In Java, C#, C++, and Objective-C, you do this by making the attribute static. So it is possible for 2 or more objects to share attribute, but you have to declare that attribute as static. For instance, as we see in the following code, public class number, static int count, public method 1 method code, and so on. Now, by declaring count as static, the attribute is allocated a single piece of memory for all objects instantiated from the class. So even if there are 10 objects instantiated from the class, the attribute is allocated just a single piece of memory. So all of them access the same memory for that object. But there's a problem there. 435 methods accessing the same memory for one attribute, for the value of one attribute. I think that can lead to so many problems because every method can change its own by assigning its own value to count, will change the value of count in memory, and that can affect the other method. So let's see. So all objects of the class use the same memory allocation for count. Uh, Fundamentally, each class has a single copy, which is shared by all objects of that class. I think that's what we just said. Each class has a single copy, which is shared by all objects of that class. This is as close to global data as we get in object-oriented design. So each class has a single copy, which is shared by all. So we have, excuse me, the class attribute memory allocated to the attribute count. So all instances of that class, object 1, object 2, object 3, object 4, object 5, object n, they access the same memory for the value for the attribute count. In that situation, I think it's going to be interesting. Now, there are many valid uses for class attributes. However, you must be aware of potential synchronization problems. Let's look at an example by instantiating two count objects. Excuse me. So you have count 1 equal to new count, count 2 equal to new count. Now, if the object count 1 is going about his business and is using count as a means of keeping track of the pixels on the computer screen, there's no problem about that. But when the next object, which is instantiated as count2, decides to use the same attribute count to keep track of students. That is a problem because they are sharing the same memory. So only one value can be in that memory at a time. So what happens? Now, at the point where count2 records its first student, the data that count1 was saving is completely lost. So this one would take, and this one would drag it from the other one. This one would drag it from. So I think it's just like three people sharing the same plate of food. You know what that can be. You cannot say all of them will have the same quantity in their stomach. The one who eats faster takes the larger quantity. So this synchronization problem is something you need to be aware of. Okay, now let's look at operator overloading. Operator overloading. So some object-oriented languages allow you to overload an operator, like C++. C++ permit that. Operator overloading allows you to change the meaning of an operator. So you can actually say that an operator has an implied meaning. Maybe an operator plus has another meaning than just adding numbers. For example, when most people see a plus sign, they assume it represents addition. Like in the equation, s is 2 plus 4. Of course, the result will be 6. And of course, that is correct. There's no other result there. But what happens if you have a plus between strings? Like if you say string first name equal to Joe, last name equal to Smith, and then string name equal to first name plus then you have maybe one space in quotes plus last name, then you're actually doing a different. The two plus signs, they don't represent addition. They represent concatenation, string concatenation. So you are joining strings, two strings to form one string. So the output from that statement will be Joe Smith. So the plus sign here has been overloaded. You see, so the meaning has been changed. And this meaning has been changed in this case to perform string concatenation. You should note that string concatenation occurs when two separate strings are combined to create a new single string. Take note of that. Now, still looking at strings, the plus sign does not mean addition of integers or floats, but concatenation of strings. What if we look at matrix addition? You could have code like this. If you instantiate or declare three variables of type matrix, and you now have a statement, an additive statement that C equal to A plus B, then you're not just adding integers or floats, you're adding matrices. And of course, matrix addition is not a straightforward operation like if you're adding two integer values. So the plus sign now performs matrix addition, not addition of integers or floats. Now, overloading is a very powerful mechanism, but it can be confusing. It can be very confusing for programmers. People who read and maintain code can be very, very confusing. And developers can confuse themselves. If you want to take this to an extreme, then it will be possible to change the operation of addition to perform subtraction. Of course, you can do that. If you can overload addition operator to perform string concatenation, then you can overload it to perform subtraction. So operator overloading allows you to change the meaning of an operator. So if the plus sign was to be overloaded to perform subtraction, then the following code, that is x equal to 2 plus 4, the result will be minus 2. Of course, you know how confusing. More recent object-oriented languages like Java, .NET, and Objective-C do not allow operator overloading because of this confusion, this complexities it can create. Although these languages do not allow the option of overloading operators, the languages themselves do overload the plus sign for string concatenation, but that's just what it is. So the designers of Java must have decided that this overloading of a thing was more of a problem and it was worth it. So they just left it out. Say, no, leave it. You know, Java is a simplified version of C++. So if you must use operator overload in C++, take care by documenting and commenting properly so that you don't confuse people who will use the class. Of course, the class is not, if you're a good programmer, if you are into coding, most of the times the work is for clients, it's not for you. So if you are overloading operators, then proper documentation and commenting must be done so that those who use the code, after you have delivered it or deployed it, will not be confused. Okay, now let's look again at multiple inheritance. The next topic, remember, I think this is the second to the last topic. There are 5 topics, so we have covered 3. This is the 4th one, and then we still have 1 more to cover. Inheritance basically is an inherent part of most object-oriented programming languages because it encourages code reuse. You don't just have to be duplicating code. Why not write code and then reuse it by inheriting what is already available? Just like in object-oriented programming is modeled against real-world objects. So like you have parents, you inherit from them. So it can be multiple inheritance. You inherit from your mother, from your father, and all that. So as the name implies, multiple inheritance allow a class to inherit from more than one class. Yeah, that is very straightforward. And this seems like a great idea in practice. Objects are supposed to model a real world. Of course, you should know that. I think I mentioned that. And you know also that most real-world examples of multiple inheritance exist. Like parents are a good example of multiple inheritance. Each child has 2 parents. Of course, you inherit from your some attributes and behaviors from your father. You inherit some attributes and behavior from your mother. So it makes a whole lot of sense if you can design classes by using multiple inheritance. And in some object-oriented languages like C++, yes, you can. You can do that. But this situation falls into a category similar to operator overloading. Note that multiple inheritance is a very powerful technique, and in fact, some problems are quite difficult to solve without it. There are some problems that need multiple inheritance. You inherit from what is already available to create new objects. Like you have the animal, like I gave you in class. You have, if you have the general class animals, you have the mammals, the amphibians, the reptiles, and all, and so on. You will see that most of the behaviors and attributes of animals are inherited by subclasses of that general class, like movement, eating, seeing, hearing, number of hands, number of legs. So most of these are just inherited from that general class. Although there are some specifics which are unique to the subclasses. So most object-oriented multiple inheritance, like I said, is a powerful tool. And multiple inheritance can even solve some problems quite elegantly. Most object-oriented programming languages, inheritance can be very useful for solving very complex problems. But multiple inheritance can significantly increase the complexity of a system for both the programmer and the compiler writers. Of course, that is true. Because, inheriting from different sources can bring about complexity of the system. Just like operator overloading, the designs of Java.NET and Objective-C decided that this increased complexity of allowing multiple inheritance for multiple far outweighs its advantages. So they just left it out. And in some ways, Java.NET and Objective-C languages construct of interfaces compensate for this. Java has interfaces which compensate for multiple inheritance. But the bottom line is that Java.NET and Objective-C do not allow conventional multiple inheritance. Not the conventional type, but they do provide interfaces. With the interfaces, you can reuse codes as much as you want. Note, interfaces are a mechanism for behavior inheritance, whereas abstract classes are used for implementation inheritance. Take note of that. And the bottom line is that interface language constructs provide behavior interfaces and no implementation. So the language construct for interfaces just behavioral interfaces. They don't implement it. So you just inherit the behaviors and use in your code. But abstract classes may provide both interfaces and how do you copy, how do you compare an object? Well, this is not as simple as it might seem because objects can contain references. These references, these reference trees must be followed to do a valid copy. If you truly want to do a deep copy, so an object can contain a reference to several other things. So how do you copy an object or how do you compare objects? Note, A deep copy occurs when all the references are followed and new copies are created for all reference objects. Many levels might be involved in a deep copy. Yes, many because there may be a reference, a pointer to a pointer, and so on. So the references, when you copy, you must be able to copy what they point to. So if you have to achieve that, you have to do a deep copy. For objects with references to many objects, which in turn might have references to even more objects, the copy itself can create significant overhead. So the objects that have references to other objects, and those other objects have reference to other objects. So if you want to copy an object that is referencing another object, and the object that object referencing, the objects that object referencing is also have references to other objects, then that copy operation can be very complicated. Comes with overhead, memory, CPU cycles. The diagram we just look at is like a reference tree because class A is referencing two different classes. And doing a simple copy will just create a copy of class A that references the same classes. Not that you are the copy will represent class A in entirety. Not actually, not just or not any of the actual objects. Now, because in most cases, languages provide a default mechanism to compare objects. Because we have said that objects contain references, and this reference trace must be followed to do a valid comparison of objects. So we must follow the reference tree. But there are default mechanisms to compare objects, but you don't need to follow this. You may not depend on this default mechanism. So when designing a class, you should consider providing a comparison function in your class that you know will behave as you want it to. So you have to provide a comparison function, a copy function that will behave the way you want it to. And that's not an easy task. So that's the end of lecture 2. In the next lecture, we are going to discuss more on the structure of a class. We look deeper into the class and see how we can model variables, attributes, and so on. For now, we are going to stop here. If you have questions, do not forget to send the questions to my email, ayei.ibor@gmail.com. That is ayei.ibor@gmail.com. Thank you, and do have a wonderful, wonderful day.